Space is an extraordinarily massive place, full of objects of all shapes and sizes. We can try to picture this extreme distance, but do we really comprehend how much space is in space? Let's try and find out. We approached random students in front of the Union on Ohio State's campus to see if they understood how large the distances between objects in space really are. We asked these students, if the Earth were shrunk down to the size of a golf ball, at what building on campus would the sun be located in relationship to the golf ball-sized Earth? So if the Earth were the size of a golf ball, how far away do you think the sun would be from here?
Probably Wexner Medical Center.
Ag campus?
I'll just say Hale Hall.
Yeah.
I'd say probably down to the stadium.
Steve Smith.
About 1,000 miles away.
In Cincinnati.
Cincinnati. It would actually be right at Thompson Statue.
That's really, really off.
This great distance offers an implication referring to the ability of a planet to sustain life. Here, we define a planet as being potentially habitable if it is able to sustain liquid water. The sustainment of liquid water requires a precise temperature on the planet, therefore referencing to a planet's distance from its star. A star gives a certain amount of energy depending on its temperature and size. This energy spreads in all directions out from the star, and as it gets farther away, it spreads more, making the energy less concentrated, and therefore the space is cooler. The range of space around a star that holds the proper temperatures to sustain liquid water is known as the habitable zone. If a planet orbiting a star falls into such a zone, it has the possibility for habitability of life. Although this zone around the star is important in determining the ability for a planet to sustain life, it is not the only factor to have an effect. How does Earth and our solar system compare to other planetary systems? One example, the Kepler-186 system, is located 500 light years from Earth. This system has 5 planets that revolve around an M-class red dwarf star that is approximately half the mass of our Sun. Because of the qualities of this Kepler star, the habitable zone of this system is significantly smaller than the habitable zone of our system. Of the 5 known planets in that system, there is one planet named Kepler-186f that exists within the system's habitable zone. The planet was calculated to have a radius of only 11% larger than Earth's. All of these qualities combined make Kepler-186f have a high possibility of being able to sustain life.
So what have we learned? First of all, there is a lot of space in space. And the implications of this between a planet and a star relate to the ability for a planet to have life. The habitable zone of a star has the potential to hold liquid water and life. Although we have not found any other planets with life, we are finding planets that possess the capability of sustaining life. With newer and higher-powered telescopes being developed, eventually we might find more planets and systems that could sustain life now or in the future.